Now, what about IPSPs, the inhibitory postsynaptic potentials? Do they adopt the same way as EPSPs? Do we have also a temporal and a spatial summation? This is what we are going to see now. Let's suppose that we record the activity of a single GABAergic synapse at its dendritic point of origin. We record a small hyperpolarization of the membrane called IPSP for inhibitory postsynaptic potential. I remind you that it's called inhibitory because this type of hyperpolarization prevents sodium channels here at the axon initial segment to open. Underlying this small hyperpolarization is an outward current, GABAergic outward current, and we saw that it results from an entry of negatively charged chloride ions. These negative charges will propagate exactly the same as the positive charges that we saw before. They will propagate upstream and downstream. But what is interesting, as I told you, it's downstream because it's the effect on the axon initial segment, which is important. They propagate the same way. It means that anions repel other anions, and like that they go down to the soma and the axon initial segment. But meanwhile also there are channels open and some charges go out and are lost. So at the very end here, this small hyperpolarization is nearly nothing, nearly not existent. So you need a lot of GABAergic synapses, especially in the dendrites, especially when they are in the dendrites, to obtain a significant hyperpolarization of the membrane here at the axon initial segment. They sum up the same way as EPSPs. You can have a linear summation when the synapses are on different dendritic branches, and you get the geometric sum of the two or many IPSPs. And you can have also a nonlinear temporal summation when the same synapse here is active several times in a row.